Okay, so we're back for the second half of Best Coding Practices, and that's lecture number 2 on coding tips. So why do we care about clean code? Have you ever inherited a project and you have no idea how the data were managed or the analyses were performed? Have you ever come back to your own project after months and have no recollection of what you did or why you did it, even after looking at your own code? It's pretty likely, happens quite a bit. In this lecture, we're going to be talking about ways to help others and future you through literate programming and clear code formatting so you don't have these problems. And so, just a note on clean coding, there are lots of ways to code the same thing. I'm sure you've all learned this by now. And so, using clean code conventions, that means we can avoid this. In order to make sure your code is fair and you're producing fair data, you want to make sure that your code is clean, readable, and well annotated. So how do we do this? Tip number 1, when you're thinking about coding, you want to make sure you use white spaces to separate processes. So using space is going to be a really important thing you're going to learn throughout clean coding. So you can see here's a set of really terrible code. There's no spaces between anything, and even if it would run, it doesn't mean that you can read or understand what it's doing. And don't worry too much about what the code is doing or saying, just appreciate the visual aspect of it. And so here's a better example of that code. While it's still not great, it's better in that you've separated out your statistical analyses from your figure code with a space. So tip number 2, you want to limit your line length to reduce scrolling because that can just get super confusing. So here in this example, we've taken those 2 chunks and limited them so they don't run off the page. So you can see that we've limited our lines. But we still have them separated by analysis and plot. And then number 3, you want to use indentation to group code together. So you want to group your light code together. So you can see in the first line, the analysis is now running onto 3 lines, and then the next 2 lines for the analysis give you something else to help you summarize your analyses or give you your marginal and conditional variance. And when you're plotting, if you're using ggplot, the second chunk of code right here, you'll often have many lines to describe your plot and to clean up your plot and make it look exactly how you want, which is something we're going to talk about in future weeks. But you can see how one line that's super long, you can indent it, and then each following line has its own set of indentations too, so you can understand what's going on. Tip number 4, use meaningful names for objects. So you could have a set of code in this bad example that it's really hard to say what any of that means. Or you could do something a little bit better where you replace your G dataset with the name gmdata, and then your column name sm10_21 with seed mass. And that allows you to understand a little bit more about what's going on. So when you look at these lines of code, you get an idea of what might actually be. These names are meaningful to a human. Tip number 5 is you want to use consistent formatting for multi-part names. So if you haven't heard about this before, the classics include dot case, camel case, or snake case, and you can see how they're formatted. Dot case has a dot between words. Camel case has an uppercase to separate out multi-part names, and snake case has an underscore. And of course, there are many variations on this, and you can see some of them here. It really depends. You can do whatever you want, just be consistent. And one thing you could consider is using one format for functions, another for data frames, and a third for variable names, just so you can keep it straight in your mind which is which. So here in this example, you can see that the function is in dot case, find dot mode. The data frame is in upper snake case, gm_data, all in caps, and the variable name is in lower snake case, so seed_mass. And I do want to point out that some formats might not work for certain types of software packages, so just be aware of that. But you never want to use spaces between your multi-part names. And so tip number 6, you could add metadata to file names. And so, we talked about metadata in FAIR data, where you have information about what your data really means. And so you could include things like the date and project name in the file name. And the reason this is helpful is because, one, it's machine readable, right? No spaces. You should have no spaces in your file names. 2, this works with default ordering. So if you have your numbers referring to dates and year, month, day with leading zeros, then things will always be ordered based on the date that you did something. And this can be extremely helpful if you keep it in your code file names for versioning when you're working on different versions of code. And these are human readable, right? They just make sense. So some examples of this are, you could have in 2017, in February 3rd, you created your raw gmtraitdata.csv file, and then 2 days later, you created a clean version of that CSV file where you cleaned up any mistakes or any errors in the data, or anything that was just messy. So those file names are really human readable. And so one thing I think that is really helpful when you're thinking about your code is to always try to write a prologue of some kind to introduce what you're doing. So just include this at the top of your code. It's all commented out, so none of it will be run, of course, but you can include your project name, the purpose, any directories you might be using so you can find your data again when you move your folders around. You can list your data file names, including whatever files you have with the correct text extensions, or if you're collecting data from a web address, you can include that here. Your name, the date it was first created, and then the latest date. And again, this is going to be super important for version control. So if you have the latest version that you're working on right here, and then you include in your notes, in the notes, you can say what is different about this version versus the previous version. And this really helps you keep track of how things are going and where you are in the process of your analyses and where you're stuck and where you need to move forward for the next time. So this prologue can just be great. Not only does it help others, it really helps you when you're trying to figure out where you were and what you need to do. And so then again, when you're working on your code, for tip number 8, you're going to want to make sure that you annotate it to clarify your code purpose. So not only do you want to include your prologue that's a really well annotation of the document in general, you also want to make sure you annotate your code as you go. So you're going to use comments to explain the reason for your code if it's needed, explain the functionality or choices that are not obvious, and identify places to return to in your code to fix. And you want to try to avoid using comments to explain poorly named objects. So here's just an example. I was creating wind averages and also converting wind speeds from kilometers per hour into meters per second. And so I had a comment here to just tell myself what I was doing in case I couldn't remember that multiplying by 1,000 and dividing by 3,600 meant converting from kilometers per hour into meters per second.
And tip number 9 is about clearing your code history at the start of each file. So for every R file you have, whether it's in Markdown or just a regular R file, you always want to make sure that you include this little bit of code, rm list equals ls, at the start of all your files before you enter your libraries or datasets. And this allows you to clear the working memory out of R, so you don't actually have multiple things named as something else. So for example, if you name something test in the system and you don't realize that you have it already saved, you could be, actually working with the wrong data set. I name a lot of things DAT, well, especially while I'm trying to figure out what's going on. And you really want to know which DAT you're actually working with. So it's really important to clear out your working memory. I can't emphasize this practice enough.
And so once you've finished your code, all of the advice that I've given so far has just been for your code documents. But then I just want to take a little bit of time to describe R Markdown to you in case you're new to R Markdown. So R Markdown is a file format. It creates polished documents that can detail data analyses and figures. And so I tend to use R Markdown once I've completed all my analyses, my code, I'm finished with all of my code, and I just want to be able to describe to others what I did in a very clear and concise way. And so R Markdown is great. It merges prose, code, analyses all in one document. And so it can be great for a metadata file. It cleanly describes your work for publications or data storage, and it's great when trying to be fair. And what's so great about this is the final document is non-proprietary, right? It's a PDF or HTML, and that can be shared publicly as opposed to simply providing people with code who may not have access to R or a computer, etc. And the files are just more attractive. They look nicer than sending someone just your syntax code, which you always could send as well, but the R Markdown has the code embedded within. So again, I tend to use R Markdown once I've done all my analyses in regular R code files. And once I'm ready to share it and have a clean version, I put everything in R Markdown. And another reason I want to explain this a bit is because all of the lecture slides I'm creating this semester will be created in R Markdown. And so it'll help you figure out what exactly it's doing and how to use it, and also how to extract code from it should you ever need anything for an example of something. So to create an R Markdown file, you open your RStudio and open up a new R Markdown document. So you can see here, you just click on the little open arrow and then click on R Markdown. And then you choose what type of document you want to create. So you can see there are lots of options, and I've created these slides in R Markdown through the presentation version. And in fact, there's actually a new option to create PowerPoint slides in Markdown that you can then edit in PowerPoint after, should that be of interest. But you can create many different types of presentations as well, HTML presentations, PDF presentations. You can even write your entire manuscript in Markdown if you want. As you can see, you can create a Word document. So a note about R Markdown syntax, you'll need to create a title for each document using YAML, which is yet another Markdown language. Don't need to worry about that too much. And anytime you open a new Markdown document, the program will already give you the prompts for what to add. And these headers differ depending on the type of document you want to create. So you can use the internet to find options for personalizing your document, but in my slide presentations, you can see that my headers look something like this, where there's a title, subtitle, author, date, and then the type of output you want and the main font, but which I've mentioned before, the font actually isn't Calibri, but somehow by putting main font Calibri there, it makes it a nicer font than the standard font. So something I still need to figure out. And I just want to make a quick note that I put things under the incorrect type, right? So I did not obviously put a date under date. And I did this so I would get the correct titles and subtitles the way I wanted them to look on the slide. And so once you're using R Markdown, you have code chunks and plain text. And so your code chunks are it's code that you want R to run, and they're in these chunks that are wrapped in backticks with R. So you can see 3 backticks and then R at the end of the top wrapper, and the bottom wrapper has just the 3 ticks. And you can see in those curly brackets with the R, you can set options for how you want R to handle each chunk. For example, do you want it to display the code? Do you want it to display results, warning messages, etc.? So here in my in my example that I have here, it shows that I want to hide any results and I don't want to have any messages. And this takes a little bit of time to get used to, so I would definitely check out the R Markdown cheat sheet for some of the many options you can include in your code chunks. Again, Googling is your best friend here if you're not sure how to show a figure but not, the messages. Just Google it and see what you can find. But this is very, very customizable once you play around with it. And so not only do you have code chunks, but you also have text options. So anything in your R document that's written outside the chunks, those R chunks, will not be evaluated by R and just display as normal text. So in my case, this slide is being displayed as normal text. And again, there are many options for syntax here as well. You can create bold font, italics font, you know, website links, headers. There's lots of options. And so check that cheat sheet for some of the many, and also use the internet. So when you're ready to create a final output file, you need to knit it. And so you click on the drop-down menu for knit, and then you choose the format that you want. So, and then once you've done this, you don't have to select it again unless you want to change your format. So you have all these different formats that you can knit to. And then it will create whatever you are looking for. For example, this is being knit to a PDF. And so once I hit knit, I get these beautiful set of PDF slides based on the code I created in R. And so just to reiterate my general thoughts on all of this coding, my general code usage is that all the information I provided at first, I use all those clean coding techniques while I'm working on non-finished products. So when I just have a .r file and I want to make sure that I am, I'm exploring my data, I'm analyzing my data, a lot of times there's so much back and forth on that I don't bother creating an R Markdown document because I have no idea what's going to be the finished product, what's going to actually go in the paper. And so, I use clean coding to make sure that my code makes sense and I can follow it again. But then I really like to use the Markdown files once I've completed a project so I know what I did, how I did it, in a super clean way. It's a really great way for sharing your code with others. So here's an example of a supplement I've created in Markdown for a paper I published. You can see, if you looked at my actual code while I was working on the project, it would not look nothing like this. Definitely not as clean and concise. But once I've finished and I know exactly what I want in the paper, then I just put it in this R Markdown file and create a really nice PDF of the output.